Good morning all. In this video, we will discuss AC fundamentals. In the previous classes, we discussed DC circuits, DC fundamentals. Basics of DC. So I'm going to ask you the question now. What is the difference between AC and DC? AC is alternating current, and then DC is direct current, and AC is having frequency, but DC there is no frequency because there is a constant, right? And AC, the cycle changes positive, negative alternatively, but in DC there is no change in cycle, it's flat. And AC we can not store, but DC we can store by using batteries. So basics of AC fundamentals. In this lecture video, definitely we are going to discuss how the AC power supply will generate, single phase AC power supply, and also how the waveforms will appear if you generate the electricity, and some definitions like time period, frequency, also like instantaneous values. That also we are going to discuss here, and average value, RMS value, form factor, peak factors, and phasor representation of alternating quantities. So we will discuss one by one now. So my question is from this slide. So here there is a half sine wave, only one half cycle we can see properly, but there is no another half cycle. So just to assume this one is a generator. So this is a conductor is rotating in the particular displacement at 2 pi, right? So the rotation is 2 pi here. So the conductor rotates one complete cycle, you will get one complete waveform, positive half cycle and then negative half cycle, you will get it, right? So this is a one logic, that's why I have not given the heading also, because we have to assume what is this. This is like generation of single phase AC voltage or generation of sine wave, right? The complete rotation gives us one sine wave, positive half cycle and a negative cycle. The conductor is positive movement here to here, that is positive cycle. If it is here to here, negative half cycle, you will get it. So same thing will be coming from the power plant to your home. See module 1b, the AC fundamentals and generation of sinusoidal voltage, definitions and frequency of generated voltage, cycle, time period, instantaneous value. This is one sine wave, right? So we'll discuss now. First one, generation of AC voltage or generation of a sine wave form, right? Just to assume there is a magnetic field is present from north pole to south pole. These flux lines, right? So 1, 2, 3, 4, 5, 6, 7, 8 flux lines will be there. You can see the picture. This diagram will give you the overall explanation of this complete topic or complete module 1b. There is a north pole to south pole, magnetic field is present. In between we placed not some conductor, only one conductor. Okay, only this one is a reflection. 1, 2, 3, 4, 5 is a reflection. Okay, so here the conductor is parallel to the field. There is no induced EMF. So see here 0. Before discussing how the sine wave is exerting or how the conductor moves, first we must know Faraday's laws and Fleming's right hand rule and Lenz's law and dynamically induced EMF and statically induced EMF. Okay, and one by one I'll be giving you now. First one is Faraday's first law. When conductor cuts the magnetic field, EMF is induced, right? And Faraday's second law, rate of change of flux linkage, that is d phi by dt, is directly proportional to average induced EMF, right? E is equal to d phi by dt, or E is equal to n into d phi by dt, or E is equal to minus n into d phi by dt if it is Lenz's law opposes cause producing in it. That is Faraday's law. Next we have Fleming's right hand rule and then left hand rule. The Fleming's right hand rule, all the fingers, I mean like 3 fingers are perpendicular to each other. Thumb shows motion of the conductor and 4 finger shows magnetic field, and middle finger shows induced EMF. That is Fleming's right hand rule. What about the Fleming's left hand rule? These 3 fingers, I mean thumb, 4-finger and middle finger are mutually perpendicular to each other, right? Thumb shows motion of the conductor, and also the middle, 4-finger shows magnetic field, and the middle finger shows induced current, right? That is Fleming's left hand rule. So right hand rule, the difference is thumb same and 4-finger is same. Motion of the conductor, magnetic field must be there. And next we have middle finger, that is induced EMF for Fleming's right hand rule, and in left hand rule induced current. Keep it in your mind. That dynamically induced EMF, statically induced EMF. Dynamically induced EMF, conductor is rotating, field is stationary. For example, you can say motor, right, or generators. And statically induced EMF, field is rotating, conductors are stationary, I mean winding is stationary. Example, I can say the transformer, right? So let's move on to the figure which we are using in the PPT. So the conductor is present over here. If it is parallel to the field, 0 induced EMF in this position, okay, in this position. And if it is perpendicular to the magnetic field, more flux lines will cut and more induced EMF, right? See, maximum induced EMF because of conductor cuts more magnetic field. That is here, this point, peak point. And next we have another one conductor, another rotation. This is only one conductor, okay, keep it in your mind, only one conductor, just one complete rotation, like one circle rotation, okay. 180 degree it comes, definitely the 0, and again 90 degree, so negative here, more induced EMF in the negative of cycle, and 360 again parallel to the field, again 0. So this is a complete one cycle, right? So this is a generation of AC voltage. So for your understanding purpose, I have taken another figure. Here there is a north pole to south pole magnetic field is present. These are the conductor. ABCD is a placing of conductor, and these are the flux lines from north pole to south pole. Here north pole to south pole there is a magnetic field is present, and then this rotates in the particular path, I mean in the 2 pi, right? So the conductor is in A position, there is no induced EMF. If the conductor is placed in the B position, see here instantaneous value, here in the C position instantaneous value is here, and D position instantaneous value is here, and E position here 90 degree, and similarly the complete cycle is present, right? So this is how we are getting sine waveform in the generators, right? See, like this we are getting the output from the generator. This you can say there is a dynamo present, so you can tell dynamo also, this diagram or this figure, right? So the conductor is present in between the north pole to south pole, and a magnetic field is present. If you rotate, the motion will be there, right? Motion in the sense rotation. If you give mechanical input, what happens? The conductor start rotating. When conductor cuts the magnetic field, EMF is induced. That is, the lamp will be glowing. When we were in childhood days, we used to play with remote cars and all. So after purchasing 1 or 2 days, after that we are dismantling the parts of we have done that actually, dismantling the parts of a DC motor, and we are doing some experiments, right? So when we were in childhood days itself, we have done an experiment of this topic. Now we are in engineering first semester, but we have done the experiment before itself, right? So just we are connecting one fan, and then we are giving power supply. So what happens? The this one, the fan will be rotating. So we have done already. And also, if you rotate the that fan, if you connect one LED lamp to the those two terminals, what happens? The lamp will be glowing, right? So we have done that experiment, but theoretically we are going to discuss now, right? And next we have a definitions of alternating quantities. We have time period, number of complete cycle. I mean time taken for completing one cycle, complete half cycle, and another one half cycle. I mean complete positive cycle, complete negative cycle, and peak to peak value plus m to minus m, and frequency, number of cycles per second, and here amplitude, maximum value of alternating quantities, and also instantaneous values. There is a alternating quantities at a particular instant, right? So that if you want a definition, you can take like this: amplitude and time period, instantaneous value, frequency. Okay, and the angular frequency, if you want, omega is equal to 2 pi by t. That is, the 2 pi is complete one cycle, and then time taken is t. So omega is equal to 2 pi of f is equal to 1 by t. Okay, thank you. Next video we'll discuss continuation part of this sinusoidal waveform.